Now we will be continuing with the exercise chapter 6 correlations. So question 7 is what? Why is R preferred to covariance as a measure of association? Here the answer will be R, or correlation coefficient, is preferred to covariance due to the following reasons. R is dimensionless or unit free, whereas covariance depends on the unit. R is easy to interpret and compare data. R lies between the range of data, which is -1 to +1. R provides clear measure of the strength and directions. Question 8 is, can R lies outside the -1 and +1 range depending on the type of data? Answer is no. Pearson's correlation coefficient, or R, can never lie outside the range -1 to +1. R is equal to what? Cov of covariance of xy by sigma of x and sigma of y, which is the standard deviation. Sigma x and sigma y is the standard deviation of x and y. Now question 9 is, does correlation imply causation? No, correlation does not imply causation. Or correlation means when the two values or variables, they tend to change together, while causation means change in one variable directly affects the change in the other variable. So correlation determines the degree of and direction of the association between the variables. So here we have an example which says that increase of use of umbrella with the increase of rainfall. This is the positive correlation, but the use of umbrella does not cause the rainfall. So hence it is a correlation and it is not a causation. Question number 10 is, when is rank correlation more precise than the simple correlation coefficient? So the answer will be rank correlation is more precise than the simple correlation coefficient or the Pearson's correlation coefficient in case of when the data are in rank or in ordinal data form, when measurements of data are not available, when outliers or extreme values are present, when the relationship is monotonic but not linear. So in these cases, what we require the rank correlation and not Pearson's or simple correlation coefficient. So the last answer is what? Does correlation means interdependence? No. Zero correlation. Zero correlation means independence? No. Zero correlation does not mean independence, but it means that there is no linear relationship between the variables. And question 12 is, can simple correlation measure any type of relationship? The answer will be no. Simple correlation coefficient cannot measure any type of relationship. Pearson's correlation coefficient or simple correlation coefficient can only measure the degree and the direction of the linear relationship between the variables. Thank you.